Have you ever stared into the night sky and felt watched? Every tiny star you see is a sun, possibly with planets, possibly with life. And yet, in all of human history, we've never heard a whisper from the cosmos. Not a signal, not a spacecraft, not even a faint, distant echo of intelligence. Only silence. And the question grows louder with every scientific discovery. Because the more we learn, the stranger the silence becomes. Our galaxy, the Milky Way, contains over 100 billion stars. Many of them are older than our sun. Astronomers now believe that at least 1 in 5 of those stars has a planet in the habitable zone, the region where conditions might allow liquid water and maybe even life. That's billions of Earth-like planets just in our galaxy. Now multiply that by the estimated 2 trillion galaxies in the observable universe, and you begin to see the scale. So why haven't we found anyone? This is the Fermi Paradox. It asks a simple question. If intelligent alien civilizations are common, why haven't we detected any? Why haven't they visited? Why don't we see their signals, their machines, their presence? Enrico Fermi asked this in 1950 over lunch. One moment he was quiet, staring into space. Then he asked, "Where is everybody?" It stunned the room, and it still stuns scientists to this day. The numbers suggest the universe should be teeming with life. That's where the Drake equation comes in. Created by Frank Drake in 1961, it estimates the number of active communicative alien civilizations in the Milky Way. It considers factors like the rate of star formation, the fraction of stars with planets, the number of planets that could support life, and how often life evolves into intelligent beings. Depending on how you set the variables, the equation suggests there could be thousands, even millions of intelligent civilizations in our galaxy right now. Yet we've seen nothing. No signals, no probes, not even any evidence. It's as if we're shouting into a void, and the void never answers. One explanation is the Great Filter, the idea that somewhere along the path from simple molecules to spacefaring civilizations, there is a wall, an obstacle that nearly all life fails to pass. It might be the leap from single-celled to complex organisms, or the jump from intelligent life to technological civilizations. Or maybe every civilization destroys itself with nuclear war, artificial intelligence, or climate collapse before it can travel the stars. So maybe we don't see them because they're all gone. But what if the Great Filter isn't behind us? What if it's still ahead? What if every civilization reaches a point of great power only to vanish shortly after? That would mean we're approaching a dangerous threshold, a point where we could vanish too. That's not just a mystery, it's a warning.
Then again, maybe they are out there, watching, listening, choosing not to respond. This brings us to the zoo hypothesis, the idea that advanced alien civilizations know about us, but deliberately avoid contact, like humans watching animals in a wildlife reserve. We might be too primitive, too violent, too unpredictable. Or maybe they're waiting for us to evolve, morally or intellectually, before they make themselves known. What if Earth is part of some vast experiment? What if we're being studied from a distance? What if they're already here, hidden? Some believe aliens could be using communication methods we don't understand. Technologies that seem like magic to us. Signals that travel through dimensions. Quantum entanglement. Neutrino bursts. Dark matter transmissions. What if they've sent messages and we just don't recognize them? The truth is, our ability to detect alien life is still painfully limited. Our radio telescopes have only scanned a tiny fraction of the sky, and we've only been broadcasting into space for a bit over 100 years. That's nothing compared to the age of the universe, 13.8 billion years. We might be like ants trying to listen for airplanes. And yet, something about the silence feels unnatural. We've sent out signals, like the Arecibo message in 1974, a binary-coded radio message aimed at the globular star cluster M13. We've launched spacecraft, like Voyager 1 and 2, each carrying a golden record with sounds and images of Earth. But no one has answered. Not even a whisper. Could it be that intelligent life naturally isolates itself? That the more advanced a species becomes, the quieter it gets? Maybe civilizations go inward, into virtual worlds, digital realities, or consciousness itself. Maybe space travel becomes meaningless when you can simulate anything you want. Or maybe we're in a quiet part of the universe, a cosmic backwater, too far from the galactic center, too boring to bother with, or too dangerous. Some scientists suggest we should stop trying to make contact at all. What if we attract the wrong kind of attention? What if something hears us and comes? There's a theory called the dark forest hypothesis. Imagine the universe as a dark forest. Every civilization is a hunter, silent and hidden, afraid to reveal its position, because out there, somewhere, might be a predator, a species that destroys any rival it finds. So everyone stays quiet, waiting, watching, hoping they haven't already been seen. And then there's the possibility that we are truly alone. That Earth is the only place where life took hold. That the circumstances that created us were so rare, so unlikely, that it has never happened anywhere else. If that's true, then we are a miracle, a cosmic accident. And with that miracle comes responsibility.
But deep down, most of us feel that can't be the answer. We sense something more, that the silence isn't absence, it's deliberate, calculated, unsettling. We've scanned the skies. We've searched radio waves, laser pulses, star systems. Projects like SETI, Breakthrough Listen, and the James Webb Space Telescope are all looking, waiting, listening, and still nothing. But what if the answer is right in front of us? What if aliens don't want to be found? What if they have rules, universal laws of non-interference? What if they walk among us in ways we can't detect? What if they're not carbon-based, not bound by time as we know it, not visible to human senses? What if the real reason we haven't found anyone is because they've already found us, and they're deciding what to do? The Fermi Paradox doesn't just ask, where is everyone? It asks something deeper, something darker. What does it mean that no one is answering? Is it because we are the first or the last? Are we unique or simply unnoticed? Or are we being avoided? As you listen to this, think about what it means to be alone in the universe or not alone. Imagine the implications. Imagine what's watching, waiting, just beyond our understanding. The stars are silent, but maybe, just maybe, they're not empty. Maybe somewhere in the darkness, something watches Earth, and maybe one day, the silence will break. The question is, when that day comes, will we be ready, or will it already be too late?